And then like 3 people out of the 9, give me something you notice about this graph, and then we can move on. What do you see in the graph before you? And let me see if I can help out by zooming in a bit. That. Hopefully it's easier for you to read. Some things are cut off, but that's okay. What do you notice about this graph in front of you? 3 people. Come on. My regulars, come on. Type something. What do you notice? Okay, good. Thanks, Victor. Amount of money each career earns. Very good. Can I get 2 more notices? What do you see in this graph in front of you? Okay, the graph shifts right the further you go down the list. Awesome. Good observation. As it shifts right, we notice on the x-axis there's dollars. On like I guess the y-axis, it's these different careers or majors, college graduates. Can I get 1 more notice? One more notice. Median. Okay, great. Thanks, Victor. So the median is present here. Let me find my pen. So on this, you should notice that this thing right here, like all of these blue boxes, they're box and whisker plots. Or if you were to draw it out like normal, there's your minimum. Or actually, it's not exactly a minimum. It's the 90th percentile, so there are some like outliers. If we were to think about this like dots, there's some people here, some people like way out here. There's your median, and then the dark blue is your Q1 and Q3. And you notice education, those college graduates earn the least, and it's career earnings. Okay, that's what stuck out for me when I was looking over this slide. I was like, wait a second, I don't earn $2 million. I wish I could earn $2 million. Even at the smallest one, they earn $1.5 million. I'm like, that's not the case. What's this graph saying? So then it's these 2 words that really hold emphasis. Projected career earnings. So that's over, like, that's from me starting my job till I retire. This is how much money they're expected to earn. Just inputs, right? It doesn't include everything that they spend on outputs, like food, housing, daily necessities, all that. So that's why they got these weird numbers, right? Everything you would think that, okay, everyone here, all these majors result in millionaires, but that's not the case. It's over, like, for education, you work 30 years and then you can retire like securely. So this is me when I'm like in my 60s. Okay, and as freshmen, it matters a little less, I guess, but you're still thinking about this for the future. What do you want to study later? Maybe how much you earn definitely affects what major you choose. I know in my household we prefer these ones. Okay, my family was like, okay, you better become a lawyer, engineer, or lawyer, engineer, or a doctor, right? Those 3 things, and here I am being a teacher. Yes. Okay, it's worth it. My parents are old in the way that they think. All right. So I've waited too long. As we go down, if you want to read more about this, you can go to my PowerPoint. It's the same one I've been using all week, and they have some more things you could have noticed, some more information about this particular graph. They go into detail, and they give you another explanation on the features of a box plot, the ranges, the IQR, the quartiles, median, so on and so forth. And then it also tells you like some of the flaws in this data representation, like it's the career is earned, but it's not necessarily guaranteed to be this case, and so it's yeah. So it's an interesting reading from the New York Times, and it's relevant to our statistics lesson on representations of data. All right. So this next part, what remains is giving you a reminder on what scatter plots and correlation are. You learned this during our data science unit. It's useful, and all these last 2 days of topics with statistics, you'll see it all again if you choose to take AP Statistics here at Lowell. I was browsing through their textbook. The first stuff is like there's the one variable statistics. Then later in their textbook, chapter 3, they start talking about scatter plots. What makes scatter plots special are that they graph two variables. Everything from before, like here. Oh, sorry. I'm like looking at my screen and then looking not on my iPad. So that like with this stuff, this is single variable statistics. It's only measuring money for majors. They only go in one dimension, so that's like left and right or up and down. But now for scatter plots, suddenly you can graph two quantitative variables, that's numbers, for the same individuals. So then they look like this. Now there's like 2 dimensions, or if you think about it even more, it's somewhat like 3, because there's also the individual themselves represented. So you want to compare things, you think about, okay, is there an association, is there correlation present? That's what we studied. And when you have a scatter plot, like the one I have in this lower right, you think about, okay, what's the general shape of my data? If I have the line that goes like this through here, it's correct to say that it is positive, it is linear, and it's pretty strong in terms of its association. Those should all be familiar words. In this case, we don't really have much outliers. If you wanted to pick one, maybe these ones over here, I guess, if you had to pick some. And what's this all saying? Now that's just the graph. We look at the units that are being represented here, okay? So on the X, we have boats registered in Florida in the thousands, and then on the Y-axis, we have manatees killed. So from this graph, you notice as there are more and more boats being registered, what do you notice happened to the manatees? Yeah, more of them, more of them die. Yes, this is a pretty depressing graph. Like manatees, the mermaids, right? The sirens of the sea, or the less luxuriously, like less flattering, they're called sea cows, right? They are big in mass, they move slow, and they occupy like warm waters where people like to have. Yeah, I think they are pretty good too, pretty cute. But for the most part, you can't see them, they move slow, and then when they get ran over by a boat, well, as most people get ran over by a boat, the outcome's not so positive, right? So that matters, like what data we're studying. Clear. So other definitions, of course, you know that lines they're always going to be a little bit off. So in statistics, we call that, and for scatter plots specifically, they're called residuals, how off you are. So over here, a residual is a measure of how far a prediction is from what is actually observed, okay? So one formula, the residual, how off you are, is actual minus the predicted. And visually, it looks like this. Okay, you have a line, you notice at the top, these are positive residuals. So those are underestimates of how much, let's see, let's look at our X and Y axes in this case. As you take more and more supplements, this is the days cold lasted, right? those are under predictions, and then down here it's over predictions. Did I get that wording right? I might have messed up with that. Let's double check. Actual minus predicted. So if my actual is higher than my predicted, then it is positive, so that's an overestimate. If it's negative, below the line, over here, my actual is less than my predicted, so it's an overestimate. Okay, so all of these should be familiar words that you got from our data science unit. And then the variable that lets us describe whether things are correlated or not, it's measured with this complicated thing. Like with standard deviation, R, this correlation coefficient is this really complicated formula, okay? We let the computer do that. We as humans are going to focus on interpreting it. So with R, we have this stuff. The correlation coefficient is a measure of how much or how little data is scattered around the least square regressions line. So that's your line of best fit. When it gets positive, or if it gets really close to -1 or +1, it's the correlation is really strong, and then otherwise it's really weak. Okay, now we have a descriptor for strength. Previously, like in this example up here, we were using a line, and then we measured just using our eyes, whether it's close or far away. Now with R, we have a number that helps describe that strength. And so the parts that matter the most, it's like this sentence frame over here. You think about R squared, right? You multiply R by itself, think about that like a percent, and you can explain R squared percent of the variability, right? That like over in our first example, that the manatee or boat spot in Florida explains the deaths of manatees. So in this case, if you had an experiment and you had an R-squared value of 0.36, you can say 36% of the variability in plant height can be explained by the linear amount of fertilizer used. Right, but that's not all that's in there. They could have other things. Manatees, for the most part, maybe there's something up with the water, or in this plant case, like amount of sunlight or the soil type, all that could affect it. That's why this is just one variable of many, right? They could all, it's not always just one variable causing one another. There's other different kinds of causes. And so with that same graph from before, you plug it into a computer, it gives us 90.7% of the data for the graph that's showing you number of months taking supplement. Negatively is correlated with days cold lasted. And so this part, kind of a reminder, you can interpret the slope and the y-intercept in context. So in here, it's showing you if you take no supplements over here, right? If you take no supplements, then you are expected to like get sick with whatever it is for 5 point something days, maybe like 5.2 days. And then as you take more and more supplements, like over here, let's find a good point. Like over here, if you take some supplements for 2 weeks or half a month, then you can expect to be sick for 4.2 days. So this part over here, the slope, all right, this negative 1.58, for those that can't see that number, 1.58, as you take each month of supplement allows you to spend 1.5 days less sick, right? It reduces the number of days you are sick, which is something you expect from taking medicine. And that's why this negative direction, this negative association makes a bit more sense. Okay, that's, I think, all I wanted to say about correlation, scatter plots, all this stuff. Any questions on all the stuff I went over so far? Nope. Okay, so for this next bit, you can follow along, have ready a piece of paper. If you want to set up like mine, you should be able to see the question I have over here on the left, and then I have my pencil somewhere. I'll write down some work on how I would solve it. If you're at home, I recommend pausing the video like now, and then following along for the answer, and then so on and so forth. I have 10 of these problems that are pulled from various places. The first couple questions I think are like from your PSAT, that's a practice SAT that you all will take as sophomores. Others come from like other standardized tests like the ACT or what else, like a math subject test, whatever resources I had, I pulled and found like these things that are relevant to us. And all of them I think are multiple choice. So worst case, you can just guess, right? So over here, for this question, I'll start like talking through it now and you can think through it too. The graph above illustrates a number of box tops collected by 4 classrooms during the school contest. The sum of the boxes collected by the 2 rooms with the fewest box tops is approximately what percent of the sum of the box tops collected by the 2 rooms with the most box tops, okay? So here, this one and this one are the most, right? Most. And then the first and the third, those are the least. I have to read my box plot, or this is not box plot, this is a bar graph, right? The first one, it had 600. The middle one, it had 1,000 box tops. 206 over here, notice it's between the bars. So we have to estimate what's halfway between 200 and 400. It's 300. And then 215, the last one over here at 800. Cool. So for the most box tops, they had a total 1,000 plus 800 is 1,800. The least amount of box tops is 600 plus 300, 900. What percent is this? 900 over 1,1800. That's half, so the answer here is 50%. So that is letter B. Yeah, you can write it. You can say B in the chat and confirm, and then I'll work through these. Okay. If you have questions, do ask them. If you got something different, very good, very good. I appreciate that you are participating. Here's your next question. Those at home, you want to pause it and like read over it. Okay. So I'll start working on this. According to the graph above, how many seniors are enrolled at Taft High School? Notice we have a bar graph on the right. We have to find Taft. So Taft originally, its student population, like everybody, freshmen, sophomores, juniors, and seniors, is 2,500. That's what the right bar graph tells us. And then we have to look at our left side for this pie chart to figure out the percent. From Taft, 15% are seniors. So this one isn't so bad. We have to find 15%. You can turn it into a decimal, multiply that by 2,500. Grab my calculator, or I can do some mental math. All right, so that's 375. So that's answer choice A. Awesome. Thank you for all those following along. Great, I got the same thing. So you see, like with statistics, a lot of it has like it's the visual, right? And then it sets up the word problem later. This one's a little bit more complicated. Shift it over a little bit so you can see it. Has a bit more reading. I'll let you think for like another minute or so. Okay, so this one's a little bit more complicated on how you would think through it, and I have to annotate on the screen now. So the first part, remembering what median means, it's like ordering everything and then crossing stuff off. You can still cross things off based on this histogram here. So if I cross off 2 people on the right, these are the most people that worked hours, then I can only cross off 2 from over here. If I cross off 1 person over here, I go 1 more. Now I'm up to 3. Okay. And then over here, there are 5 people. Crossed off 3 so far. So there's another 3, and then I cross off another 2. And then I cross off another, what is this, 9 people from this graph. And so from 3, I go all the way up to 12, right? So it seems like my median is going to be somewhere in between here. It's going to be, let's see, not knowing how many people there are, you can say that it's between 20 and 30. That's your median. So that's probably one of these 3 answers. And then we have to go investigate. Now we got to think about the mean and what that looks like. So for, oh, I'll just leave this up, okay? Let me change colors. Now for the mean, maybe I'll think in red, okay? Where is the mean going to lie around here? Well, you think about if you were to even this out, if you were to average this, like 70 plus all this, you could do that by hand. But visually, you can see that, okay, the mean is probably not going to be in this first bar. It's not going to be on the second bar. It's probably going to be somewhere in the middle over here, right? Mean. Because all these people that work 20 and 30 hours, they would eventually cancel out the people over here and it would shift it to the right a little bit. Like imagine covering the last 3 bars, right? And then your mean would probably be in that big tower, right, between 20 and 30. But since you have these outliers here, the mean is not sensitive to these outliers, these people that works 50 plus hours. It's going to be drawn to your right. It's not going to be stuck in between like your median is over here in this range. So the answer here should be C. And I put the answer in the notes. Let's see if my thinking was correct. Okay, let me go back. All my chicken scratch. And then where are my speaker notes? Show speaker notes. Blast. I did it wrong. The answer here is D. So where did I mess up? I messed up with the median, I guess. My canceling. So, did I cancel one too many? Is that why? Because now it's saying my median, so in the green where I circled, I think it should be over to the right. I miscount this. 6 people here, 2, 3, 5, 6, 2. Huh, what did I do wrong? Well, okay, so I'm wrong. Oops. So it looks like I have to go back. Maybe by 4 p.m. I'll have a better answer. I'm pretty confident in my process, but I'm not sure about my mistake. Sorry about that, class. Let's just go on to the next one. Oop. Okay, this one reviews standard deviation. All right, so for this question, we have standard deviation, we have some quiz scores like the ones I showed you from before. We notice both classes, they have the same amount of people, that's the same amount of dots. And it's asking you which of the following statements about standard deviation is true. So choice A, the standard deviation of the quiz scores in class A is less than the quiz scores in class B. So remember for mean, right, thinking about average in that way, standard deviation measures spread. So option A is saying that the spread in class A is less than all the spread in class B. Visually, that seems to be true, as you notice in class B, it's very spread out. All the people scored all the scores. There's really big spread in class B. There's less spread in class A. That's what answer A is saying. So far it looks good, but we can investigate these other results. Option B, the standard deviation of the quiz scores in A is greater than the quiz in B. Well, that's not the case, it seems. There's more quiz scores in 3s and 4s, there's less variability there. Probably not B. C, the standard deviation of the quiz scores in A is equal. Nope. And then option D, there's not enough information to compare the standard deviations. There is. We can figure out the standard deviation of these scores. Okay, so the answer here is in fact A. All right, here stats practice 5. Oops. So this one has a little bit of algebra applied to the average formula. Okay, so for this one, there's an order here. A is the smallest number, B is the next biggest, C, D, and E. Integers just means that they're whole numbers, they're not decimals. If B equals the average of A and C, so its formula looks like this. Since there's only two numbers, we divide by 2. And D is the average of C and E. Then it's asking you B plus D equals blank. So once we make that substitution, okay, over here, B plus D, the average, right? So you can substitute, don't forget this part, because I'll write it in red. When we do average, right, that's the average. So the sum of B and D is not going to be enough. Since there's two numbers here, you have to divide by 2. So then this becomes A plus C over 2 plus C plus E over 2, all divided by 2. We'll focus on this first part. We can rewrite it A plus C plus E all over 2. We're adding fractions, and all that is being divided by 2. We can then simplify A plus 2C plus E all over 2 divided by 2. When you divide this fraction like that, and I know it looks a little weird because it's a fraction and a fraction, you can rewrite it like this, A plus 2C plus E over 2, like times 1/2. That's the same as dividing by 2. And so our answer is A plus 2C plus E over 4. That answer choice looks like it is C. A little bit of algebra. Is it C or E? Oh, E. Thanks. E. Let's see. Moment of truth. Blast. Because it's so why did I write C? I got E. Alright, looks like I made another mistake. Okay. Review, I got it wrong again. The algebra looks right to me. Maybe I just messed up my answer key. Algebra looks right to me, so I think it is E. So let me just double check that. Sorry about that. I'm pretty confident that it's E, right? Algebra looks right. I think this original one, if we pick C, that's missing this part over here, the divided by 2, right? You just found the sum of B and D versus the average of B and D. So I'll go back and check it. Sorry about that. Stats practice number 6. Make it a little bit bigger. You are finding the mean. Now you have some variables in there. Cool. So the average, meaning the arithmetic mean of m and n is p. So then m plus n plus p divided by 3, because there are 3 numbers, equals 8. If m and n equals, n plus n equals 15, then p has to equal what? Well, one substitution you can apply here. And so you know that's 15 plus p divided by 3 equals 8. Okay, sub. That's from the problem. Now you can just solve for p. Some undoing. Multiply by 3 on both sides. 15 plus p equals 24. P minus 24 minus 15, that's 9. That for sure is answer D. Okay, awesome, awesome. All right, let's double check. Okay, this one was right. I really think my answer keys are wrong for some of these. Here's the next one, number 7. We got a total of 10. Well, this one I can zoom in a bit. Find the median. So I'll just start sorting them. That should be your first step here. 1, 2, 7, 22, 52, 97, 100. And then you begin crossing things off. You know for sure it's not 1 or 97, right? Because those are like too big. Nice. Awesome. I got the same thing. So it's easier when it is an odd number. So there's not 2 in the middle. Remember, if there are 2 things in the middle, then you have to find the average of them. Don't forget the sorting. Right. So if you guessed 97, it's likely because you started crossing off numbers, but realized that for the median, they have to be sorted. It has to be greatest to smallest. Careful about that. Sort first. Right. There's number 8. I think I have to get started with this one alongside you because it's going to take a while. Remember, those at home, you would pause and work through this yourself to get the most out of this video. All right, you should have 12 numbers each because there's 12 months there. Make sure both your columns have 12 numbers. Don't mind my dash marks. So for my high, I got the average of 56 and 60. I think that's 58.5. No, 58 exactly. Yeah, cool. Awesome. I also got B. So that from the process of elimination, we save our work. I started with high, maybe you started with high too, or maybe you started with low. It looks like for low, yeah, we would have gotten the same thing. If you got 37, in this case it's unique, so it is answer B. Part of the test taking strategy is like, okay, you don't need to actually solve for the low here because you already know, just based on the high answer you have it sort. And this problem reminds you if you have two numbers for your median, then average them. Okay, here's stats practice 9. Combining now the mean and the median idea. Sorry, it got cut off. Is -1. Cool. Yeah, at first it was cut off because I zoomed in like this, right? And I didn't tell you what the mean was, so you couldn't answer the entire problem. Did I do it? Did I solve it right? I messed up my signs. So I think here the answer is A. And I'll talk through my process, right? So you have some mystery number n. The part that got cut off originally was this -1 idea. -1 is the arithmetic mean. So when you average these four numbers together, 1, 7, 9, and n, they should divide by 4. Yeah. And then there's two steps. Then you got to order them. Remember to put -21 over there, and then you have to take the average of 1 and 8. Not so bad. All right, last one. Stats practice 10. This one has the mode appear. Remember, the mode is the number that appears the most. Awesome. Got the same thing. Student B. Mode was a little bit easier. Don't forget the sort again. That seems to be the ongoing theme for test for medians. Okay, and then the mean, it's algebra, and that's all. That's today's lecture class. I hope you enjoyed this little format. It's a little different. You can always go back to these questions and review them on your own time. Thank you for those that were able to participate. I think I moved a little fast, but it's hard. I'm adjusting. I can't see your faces working on these problems. So it's harder for me to adjust. So I'm always open to feedback during these sessions. Let me know. You can always stay a little while and get more help. Yes, we'll be seeing each other on Tuesday. Well, Raymond, we also have Reg, right? So I need to send out an email for Reg. Yeah, yeah, Monday for us. Yes, I think Reg is on Monday. I'll make like a Google Meets or something. Yes, yes, very good. Yes, 2317 is the best. Very good.